Hello everyone. Today we're going to do a package user of CCNA3 version 7, 5.4.13 package user. Configure extended IPv4 ACLs scenario 2. This is addressing table. Part 1, configure a named extended ACL. Part 2, apply and verify the extended ACL. Background scenario. In this scenario, specific devices on the LAN are allowed to various services on servers located on the internet. Instructions. Part 1, configure a named extended ACL. Configure one named ACL to implement the following policy, the 3 policies. First, block HTTP and HTTPS access from PC1 to server 1 to server 2. The servers are inside the cloud and you only know their IP address. Okay, here, the block PC1 to server 1 and server 2 in the cloud. For the HTTP and HTTPS, okay, this is the IP address of server 1 and server 2. The second, block FTP access from PC2 to server 1 to server 2. Block FTP from PC2 to server 1 to server 2 in the cloud. Third, block ICMP access from PC3 to server 1 to server 2. Block ICM from PC2 to servers. Okay, so note for scoring purposes, you must configure a statements in the order specified in the following steps. Step 1, deny PC1 access to HTTP and HTTPS services on server 1 and server 2. The A, create a named extended IP access list on router RT1. This is router RT1, which will deny PC1 access to HTTP and HTTPS services of server 1 to server 2. 4 access control statements are required. Use limited access as the name of the named access list in this activity. What is the command to begin the configuration of an extended access list with the name limited access? Limited access, this is the name of ACL we are going to use to configure the ACL. All right, so what is the command to begin? Okay, let's go. And here's a router RT1, enable a configure terminal. All right, so because this is extended named ACL, so we need to start with IP keyword, IP access list. Okay, then is extended or standard? Extended, we extend it, and what? The name is limited access. Limited access, this is the name. Okay, limited access, remember this name. And that's it, okay. So B, begin ACL configuration with the statement that denies access from PC1 to server 1, only for HTTP, port 80. The port 80 is for HTTP. Refer to the addressing table for IP address of PC1 and server 1. PC1 and server 1. Okay, look at the PC's IP address. The first 3 number, the decimal number, are the same. The only difference is PC1 is 101, PC2 is 102, PC3 is 103. And server's IP address, the first server 1 is 101. All other numbers are the same. Server 2 is 103. Okay, so let's start. B is deny PC1 to server 1 for HTTP. So deny TCP from PC1 to server 1 is host to host. So source address is PC1's address. Host, PC1's IP address. PC1's IP address is this one, PC1's IP address. Then the destination IP address, the host, destination host, and the server 1's IP address. All right, so EQ equal is for what? For 80 for HTTP. So block the HTTP traffic from PC1 to server 1. So 80 is, I use this one, you will see you're more clear. Okay, here, so 80 is the port number. www is the port keyword. You can use either way, www or 80, but here they ask us to enter 80, so we enter 80. Okay, so this one is down. Next, the understatement that denies PC1 to server 1 for HTTPS. Okay, this time is HTTPS. So the port number is 443. The 443 port number is for HTTPS. All right, so we use up arrow. All this information are the same. PC1 to server 1. Okay, the only difference is the port information. This is a 443. Okay. So next, D, enter the statement to deny access PC1 to server 2. Okay, this time is the server 2 now, only for HTTP, refer to the addressing table. Okay, so we still use up arrow. So still PC1 to server 2. Okay, this one is server 2. Server 2 is 103. Okay, here. So here, 103. This is a PC, server 2, 103. Okay, here. PC1 to server 2 is here. Okay. And oh, PC 103. Okay, we need to change this to HTTP 80. All right. So next is PC1 to server 2 for HTTPS. Okay. Up arrow. PC1 to server 2, correct? Only difference is the port 443. All right, so we finish PC1. The step 2 is deny PC2 to access FTP services on server 1 and server 2. Go refer the addressing table for IP address of PC2. Enter the statement that denies access from PC2 to server 1 only for FTP. Port 21 only. The port 21 is for FTP. So we up arrow deny. This time is PC2. Okay, PC2 IP address is 102. Okay, this is the source PC2 address. Destination is server 1. Server 1 is 101. All right, good. And the port is 21 for FTP. Okay, here is FTP 21. Okay, good. PC2 to server 1, 21. Okay, next is PC2 to server 2 for FTP. Okay, up arrow. Server PC2 to server 2. Server 2 is 103. 103. And here is 21. It's correct. Same. All right. So PC2 is done. Next step, step 3, deny PC3 to ping server 1 and server 2. Refer to the addressing table for the IP address of PC3 state. Enter the statement that denies ICMP access from PC3 to server 1. Okay, PC3 to server 1. Okay, deny. Okay, This time is deny ICMP. Deny ICMP. So we need to change this one. Okay, so PC3 is 103 here. PC3's address, IP address. 103, PC3 to server 1. Server 1 is 101 here, IP address. And no, we don't need to specify the port information because this is for the ICMP. Okay, we need to change this ICMP. ICMP host PC3 to server 1. Okay, correct. So next one is PC3 to server 2. Server 2, up arrow, still deny ICMP. PC3 source is server 2 is 103. Okay, other numbers are the same. Okay, good. All right, so we finished these three pieces. So step 4 is permit all other IP traffic. Okay, by default, an access list denies all traffic that does not match any rule in the list. Enter the command that permits all traffic that does not match any of the configured access list statements. Okay, so we need to do what? We need to permit all other IP traffic. So it's permit IP traffic from any source to any destination. All right, so enter. So our configuration is done. Step 5 is verify. We need to verify our configuration now. Verify the access list configuration before applying it to an interface. Before any access list is applied, the configuration needs to be verified to make sure that there are no typographical errors and that the statements are in the correct order. To view the current configuration of the access list, use either the show access lists or the show running config command. So let's go to show command. So let's go come out. So show, first is show access list. All right. So everything is the same. Extended IP address list. This is the name, limited access. Remember this name. Okay, here is the 10, 20, 30, 40, 50, 60, 70, 80, 90. This is the sequence number or the 9 number. Okay, are the same. Okay, then it's show running configuration. The begin access list. All right. So everything is the same. Limited access. This is the name. Deny. Okay. Permit. Correct. Well, correct. Okay. But here the note the difference between the output of the show access list and the show running configuration command is the show access list command includes the sequence number. Yeah, this is sequence number 10, 20, 30 to 90. This sequence number assigned to the configuration statements. Yeah, this sequence number enable the editing, deleting, and inserting of single lines within the access list configuration. Sequence number also define the processing order of individual access control statements, starting with the lowest sequence number, starting from the lowest is 10. Yeah, from 10 to 90. All right, so we verified. Now we need to apply this ACL. Apply and verify the extended ACL. The traffic to be filtered is coming from the, okay, from this network. It's a 172.31.1.96/27 network. It's this network. This is and it's destined for the remote networks. Remote networks is on the internet. So the source, this is the source from these PCs and destined to the remote network, the servers. Okay, so the direction is from the left to the right. Okay, this is source, this is destination. All right, so appropriate ACL placement depends on the relationship of the traffic with respect to RT1. In general, extended access list should be placed on the interface closest to the source of the traffic. So this is the source of the traffic. So on router RT1, this interface G00 is closest to the source of traffic. So we need to place ACL on this interface G00. Okay, and okay, and in actual operational network, untested ACL should never be applied to an active interface. This is not a good practice and can disrupt the network operation. So on which interface should the named ACL be applied? Should placed on G00. Yeah, because it's close to the source of traffic. Which direction? Direction is in, because the direction is from the source to the right destination. So this interface is the inbound enter router. So inbound interface. So in, the direction is in. All right, so let's enter the configuration command to apply the ACL to the interface. So configure terminal interface G00. Okay, so IP access group and what? And access name. Access list name is limited. Limited. Supposed to be this name. Limited access. Let me copy paste. All right, so and the direction is inbound. All right. So the applied is down. So we configured and applied. So our work is supposed to be down. The completion is supposed to be 100% here. Okay, but we only get 20%. Why? Because before test, I will explain you something. The answer, the Cisco gave the answer to this packet tracer is not totally right. I'll explain you why. Let's test first. The test is supposed to be the 100% correct. All right, so test access for each PC. A, access the websites of server 1 and server 2 using the web browser of PC 1. Okay, so use both HTTP and HTTPS protocols. Use show access list command to view which access list statement permitted or denied the traffic. The output of the show access list command displays the number of packets that match each statement since the last time the counters were cleared or the router rebooted. Note to clear the routers on the access list, use the clear access list counters command. Okay, let's go to PC1. Let's test one by one. Start from PC1. Browser, go to browser, and HTTP from PC1 to server 1. All right, so here, paste. This is HTTP from PC1 to server 1. This is server 1. All right, so it's supposed to be blocked because here's a block HTTP from PC1 to server 1. Yes, the request timeout. So that means it's denied. Let's copy. And let's come out and get in. this time we test HTTPS from PC1 to server 1. Yes. Okay. Supposed to be blocked as well. Yep, request timeout. Okay, so now we need to, from PC1, come out and get in again. So this time is from PC1 to server 2, HTTP. All right, so HTTP. Okay, so yes, timeout is blocked, denied, also called denied as well. Okay, this time we HTTPS from PC1 to server 2. Okay, need to be denied as well. Okay. Yep, it's perfect. Perfect. Okay, we test from PC1 to server for the browser, HTTP, HTTPS. The second access FTP of server 1 and server 2 using PC1. Okay, it's FTP from PC1 to server 1. Okay. Supposed to be FTP. Yes, should be permitted. Cisco. Why? Why? Because FTP only block PC2 to servers. Now we're on PC1. So now we need to wait. We need to get back to PC. Okay, the PC1. Then this time is FTP to server 2. Server 2 is 103. Yes, Cisco. Yes, we enter FTP, so that means if PC1 is permitted to PC1 is permitted to an FTP PC server 2. Okay, so this is permitted. Okay, next is ping from PC1 to ping server 1 and server 2. Okay, ping. This is server 1's IP address. Ping supposed to be permitted. Yes. All right. So next is ping server 2. Server 2 is 103. Is permitted. Correct. It's perfect. All right. So we finished test PC1. Then we need to test repeat step 2A to step 2C with PC2 and PC3. Okay, let's do PC2. Repeat the process. Browser, start from browser. Okay, browser, FTP, HTTP from PC2 to server 1. HTTP2, yeah, it's permitted. Good. Getting this time is HTTPS. Permitted. Okay, now is from PC2 to server 2. HTTP is permitted. Good. And let's get out. Okay, PC2 to server 2, HTTPS. Permitted. Good. So everything is going as we expected. All right. So from PC2 to FTP server 1 to server 2. Okay. So FTP server 1. FTP server 1. Okay, it's supposed to be blocked. Yes, because here, block FTP from PC2 to servers. So here is blocked. Yes, disconnected from FTP server. Right. Then we FTP server 2, 3. Yeah, blocked as well. Yeah, okay. So this time will be ping. Okay, it's ping servers from PC2. So it's ping. This is PC1 server 1's IP address. So ping from PC2 to server 1. Yeah, it's permitted. And ping server 2 is 103. Yeah, permitted. All right, so let's go to PC3 and repeat to the process. Browse. All right, browse. Server 1. And yeah, permitted. Permitted. And copy. Get out and come in. And this time is to HTTPS to PC from PC3 to server 1. Okay, it's permitted. Good. All right, we test. This time is server 2. Okay, permitted. Good. Okay, so HTTPS. Okay, permitted. Good. So now we need to FTP from PC3 to servers. FTP server 1. FTP server 1 supposed to be permitted. Yes, Cisco. Yes, we enter FTP. That means we're permitted. So quit. Go back to PC. Then FTP server 2. Cisco. Yes. Okay. Quit. Okay. So next we need to ping. Server 1 and server 2. This time supposed to be blocked because here the ICMP will be blocked from PC3 to servers. Okay, ping. This is a PC1 server 1's IP address. Ping. It's destination host unreachable. That means it's blocked. Then ping server 2. 3. Destination host unreachable, blocked. It's perfect. Yeah, our testing is finished. Okay, everything we're done is perfect. Yeah, as I said, the answer the Cisco gives this packet tracer is not totally right. Is because this packet tracer has an old version of 2020. In the old version, they use the name the ACL. Okay, here the name is limited access. This is the name of ACL. But in the older version, they use ACL as a name, not limited access. Okay, so this is a new version. But in the new version, they still keep the old answer. They still keep the old answer, keep the old name ACL. So that's why, okay, I show you. Okay. I show you what I'm talking about. Show, okay, show run. Okay, here is the application we configured. All right, everything is perfect, is right. This is the name of ACL. And here is the application. We apply the ACL to this interface, G00. Okay, here, limited access. All right, the two names, limited access and limited access, these names supposed to be the same. Okay, we are doing the right. But in the answer, the Cisco keep the old name, ACL, as a name in the answer. So that's why they say they don't give us the 80% of the configuration scores. Okay, I show you more. Configure terminal. Okay, so let me change to the old name. You will see no. Okay, copy, paste. Okay, so no, so no. All right, so I change the name to the ACL. Okay, that is the answer they put in the answer, ACL. They use this name. Okay, they use this name ACL as a name, not limited access. Okay, let me copy paste this configuration to this new, their name. Okay, here, look at here. Here's 20%. Remember, 20%. Okay, let me go. Here, completion 100%. So that's why, that's what I'm talking about. So in their answer, they use ACL as a name, not limited access. And do show run. Okay. From here, you will see, here's the configuration. Extended, access is extended ACL. This is the name. This is the configuration, all right? But look at here, the application, gigabit 00. Here, use the name limited access. So these two names supposed to be the same, but here they're different. So their answer is wrong. Okay. Hopefully you can understand what I'm talking about. Here is completion. But if we use this configuration to do the test, the last part, test access for each PC, the test will fail. All right. So I hope you can understand what I mean. And I'm not going back to my previous configuration. You guys can go to try. Hopefully, Cisco can correct this answer for this packet tracer. All right, so we're done for this packet tracer. Configure extended IPv4 ACLs scenario 2. All right. So thank you for watching my video. If you like my video and think it's helpful for you, please thumbs up and share with your friends and subscribe my channel. See you next time.